Okay guys, I'm in the courthouse in the morning, so you may hear noises in the background. There's not a lot I can do with it. I don't have internet access through the day, so I'm trying to get this set up for you. Okay, so a stunt biker is racing backward during a movie scene. So the work done by the normal force is positive, negative, or zero. So this is some dude on a bike. Oh, I don't think I can draw bikes very well. Okay. And he is going backward, so he is physically moving this way. And they're asking about the normal force. Well, let's draw out the forces acting on this guy. There is a force normal. There is a force of gravity. Those should be equal. And friction always fights the direction of motion. So force of friction this way. And there's some engine or something doing an applied force forward. So those should really line up, but I didn't draw them very well. We're just really focused on this normal force, so we don't have to worry about anything but this guy right here. So what the equation for work is equal to force times the distance times the cosine of the angle between them. So work is equal to, well, we're really going to be focusing on this. The object is going this direction, and the force is this direction. What's the angle between them? It's 90 degrees. So work is equal to force times distance times the cosine of 90 degrees. Cosine of 90 degrees is 0, so work is 0. And that makes sense because work in this situation, or normal force in this situation, is not doing any work. It's not pushing you forward, it's not slowing you down, it's not really affecting anything, so you would expect it to have 0 work. Okay, now we have a toy box that's getting pushed forward. So we'll just say this is forward. It's going that way. And the forces that would be acting on it, well, really similar to the bike, actually. We have a normal force going up. We've got gravity going down. We have friction fighting the motion. And we got a force applied pushing this forward. And the work done by friction is, okay, so this is the direction the object is moving. And we're doing work is equal to force times distance times the cosine of the angle. Let's focus on that cosine of the angle. So so we're focused on our force of friction, which is this way, and the object moved this way. So what is the angle between them? That is an angle of 180 degrees. So we would say that this will be ultimately the cosine of 180 degrees, and you can put that in your calculator if you don't have it memorized. That is -1. So whatever you get here, your work is going to be negative. And that makes sense because friction is stealing energy. It's taking energy away. It is slowing the box down.